Alright guys, this is day 2 of Hyperbolas, but before I go over the homework from the other day, over 1, 2, and 6 off of the worksheet, I want to do a little bit of a review. So if you could either get out a sheet of paper with a ruler, or if you have graph paper, I want you to take a look at these 3 questions referring to this equation here, x equals negative y squared minus 6y minus 5. First of all, determine what type of conic section this is going to graph, then write the equation in HK form, and then go ahead and graph the conic section. So go ahead and pause the video and work a little bit on that, and then you could resume the video just to see what you're coming up with. So let's take a look at these answers here. All right, notice if we have an x is not squared, just the y variable is squared. So this tells us we actually have a parabola. And based off of this, because it's an x equals and the y is squared, it's going to open sideways. And because a, the leading coefficient here, is -1, this parabola will actually open to the left. So just a little bit of extra information here. What I'm going to do is scroll down to get this in HK form. All right, so we are looking at, scroll down to stay down here. All right, so we're looking at x equals negative y squared minus 6y minus 5. So we want to complete the square. We're going to leave the x over here. I'm just going to show the completing the square, even though there's a couple other ways we can come up with this. I want to start out of the first 2 terms here. I want to factor out a negative, which will leave us with a positive y squared plus 6y. Leave a little bit of space here, then the minus 5. So what we're going to add in here, half of 6 is 3, 3 squared is 9. But I didn't really just add a 9 here. If you take a look, this is a 9, but I need to multiply it by this -1 that's out in front. So I really subtracted a 9 from this side of the equation, which means I want to add a 9. So now we're going to say x equals the opposite. This quantity now becomes, this will factor into a y plus 3 squared. -5 plus 9 will give us a plus 4. So this is the HK form. Remember now, because this is a sideways parabola, over here is our h, inside the parentheses is our k. So our vertex here is going to be 4. We always want to say h then k. And then the 3 is going to be negative. So there is our vertex, not a center, because parabolas don't have centers, but we have a vertex. We know a is -1, so this will open to the left, as I just mentioned above. What else would we need? Just to write this out, the axis of symmetry is going to be horizontal, so it's going to be y equals k, so y equals a -3. So go ahead to your graph paper, or go ahead and draw your coordinate plane. And we want to plot the ordered pair 4, -3. Keep in mind, however you start to number, if you do number by 2s, you have to indicate that on your x and y axes. Notice here I've got the 10s all around at the edges here, so I'm indicating that each block here is counting as 1 unit. So now, for this to open to the left, and with a being a -1, if I count up 1 for my vertex, I'm counting 1 to the left, down 1, 1 to the left. Go back to the vertex, we count up 2. 2 squared is 4, so I'm going to count 4 to the left, down 2, 4 to the left, and that's enough of points to get a nice shaped parabola here. Just to draw on the axis of symmetry, right in the middle, it is a horizontal line at y equals -3. And remember, when you're done with this, you can always go to Desmos or your graphing calculator, type in the original equation, then type in the vertex form. They should give you the same parabola. If they do, you know you did that correctly. If not, go back and check your work. Chances are maybe you thought you needed to subtract a 9 or add a 9 there. So always watch your signs as well. All right, so let's take a look at our homework problems from yesterday. All right, so for number 1, we were given x squared over 16 minus y squared over 49 is equal to 1. So we were asked to do a couple things with this. Identify the center, the vertices, and the slopes of the asymptotes along with graphing it. So this is already in HK form. Our center, because there's nothing up here with the x and the y squared, our center is just going to be 0, 0. As I mentioned, that's all day one. The centers were at the origin. Today they're going to be a little different, shifted a little differently. All right, so we could plot our center right here at 0, 0. Underneath the x squared is always, in our first denominator, is always a squared. So a squared equals 16, and a is going to equal 4. B squared will equal 49, so B equals 7. We also need to know the direction of this. Is it going to be east, west, or north, south? So whatever comes first is going to dictate that to us. So because the x term is the first numerator, this is going to be an east-west, so a sideways hyperbola. And the slopes of the asymptotes, we'll figure out the vertices later. The slopes of the asymptotes, we always go with whatever's underneath the y, that's our rise. Whatever's underneath the x, that's our run. So it's going to be plus or minus 7 over 4. Or if you go back to your notes, it's, in this case, if it's an east-west, it's plus or minus b over a. So I'm going to count up 7 and then over 4 to the right, up 7 over 4 to the left, down 7 over 4 to the right, and then down 7 over 4 to the left. And we're going to go ahead and draw our rectangle. Remember, the rectangle and the diagonals, those are our guidelines to help us draw the hyperbola here. So there's my rectangle. And we're going to draw in our asymptotes here. I like to use a dotted line just to separate this here. Let's go ahead and draw this in. And again, make sure you go through the corners of the vertices of the rectangle here. As best we could draw that. All right, so now the vertices of the hyperbola, if this is an east-west, it's going to go on the left and right side of the rectangle, right in the middle. And we could actually answer that part here. So this vertex on the left is actually going to be at -4, 0. The other vertex right here will be at 4, 0. So when our center is at the origin, our vertices are either going to be right on the x-axis or the y-axis, which makes them nice to quickly write out. When we go to draw this, though, do this very carefully. If you're not perfect, that's fine. I'm not going to be perfect here either. But we're going to be very close, and since it's east-west, we have a rather wide hyperbola to draw here. So try to go as close to the diagonal, the asymptote, as you can. Try not to go through the rectangle, but just to, as I say that, let me draw this again. Try not to go through the rectangle, just touch at the vertex. And then get very close to that asymptote again. So we have a very wide hyperbola here. Likewise on the other side, if you want to start at the vertex, it might be a little bit easier to draw it that way. There we go. All right, so we stated our center at 0, 0. The slopes of our asymptotes, we could just keep it as plus or minus 7/4. And then our vertices, we're at 4, 0, and then -4, 0. So that's answering all the parts we needed to for number 1. Number 2 is going to be very similar. And please, guys, at any time, let me know if you have questions. Email me anytime that you do. As far as homework, just keep track of it, hold on to it. If we do return, I'll take a look at it then. You don't have to submit every homework assignment, just keep track of it, make sure you're doing it, check with the homework answers as I post them. All right, so for number 2, again, our center's at 0, 0. Our y-squared is now first, so this means we're going to have a north-south facing hyperbola. So one's going to open up, the other one's going to open down. Again, a squared is always our first denominator with a hyperbola. So a squared equals 36 means a equals 6. B squared equals 9, so b equals 3. The slopes of our asymptotes, plus or minus whatever's under y, the square root of that is our rise. The other number, the square root of that, is our run. So we're going to take the square root of 36. It's going to be plus or minus 6 over 3. Now, this is the one case I was telling you we do not want to simplify that. Yes, the slope could be simplified, but we need it to stay 6 over 3 for the size of our rectangle. So for right now, I'm just going to leave it this way. Put our center at 0, 0. We're going to count up 6 and 3 to the right, up 6, 3 to the left, down 6, 3 to the right, down 6, 3 to the left, and we're going to draw our rectangle there. Okay, drawing our diagonals, our asymptotes that go directly through here. All right, so there's our diagonals. Again, because this is a north-south hyperbola, we're going to put our vertices right in the middle of the top of the rectangle and then the bottom of the rectangle. So to write these vertices out, now these vertices are falling on the y-axis, so they're not tough to figure out the ordered pairs form. So down here, we're going to have a 0, -6. Up top, we'll have a 0, +6. So our vertices are at 0, 6, and 0, -6. And then to draw the hyperbola a little bit nicer, they're not as wide. We're going to start getting very close to the asymptote, go through the vertex, and then up this way. Likewise at the bottom. All right, so again, just to show you, try to do that as best as possible. What I don't want to see is something like this. That would not be correct. We want to stay away from that. So make sure that we are trying to get as close to the asymptotes as possible. Go through the vertex. So like that. That's as accurate as we can draw. Remember, you can always check this on Desmos. One thing that might be a little bit tougher is you're not going to see the rectangle or the diagonals there for the slopes of the asymptotes. You could still draw in or type in the equations of the lines of the asymptotes, but it's a little bit more work. So all you have to do to check on Desmos is to check your vertex here and here, and maybe pick some points on that as well. But that's the best way to look at that. All right, looking at number 6, all we had to do, not so much work here, is just to write this in HK form. So we're looking at 16y squared equals 25x squared plus 400. Now keep in mind, every time you're looking at these problems, even though all of these are hyperbolas, just double check it to identify them. So in this case, we want to get the x squared and y squared on the same side. So we have 16y squared minus 25x squared equals 400. At this point, we could identify this as a hyperbola because we see an x and a y squared both on the same side, but one has a positive coefficient, the other one has a negative coefficient. We want to get this in HK form though, so at this point we want to divide everything up here by 400. Now 16 times 25, think if you have 16 quarters, you have $4. So they multiply to give us 400. So we're going to end up with y squared over 25 minus x squared over 16 equals 1. So that's all we had to do for this problem. All right, so now we're going to take a look at some examples where the center's not at 0, 0, and we're going to practice completing the square once more as well. What I just want to go back over, the notes that you guys took on day 1, so you don't have to write these down. just good to revisit them. So again, we have a north, south, or east-west facing hyperbola. When it is east-west, it's the x quantity that's first in our first numerator, and then the y quantity is in our second numerator. When it's a north-south, the y quantity is our first numerator and x. So again, x and y switch. The a squared and b squared stay where they're at. So a squared is always a first denominator, b squared is always a second. The center is still hk, but take a look over at the north-south where the h and k are. So to write out the center, you get the h from the second numerator and you get the k from the first numerator. Be very careful with that. It's very easy to look at it too quickly and write them in where they need to be switched. Again, here are the slopes of the asymptotes. What I refer to this as an easy way to remember is whatever's underneath y, that's the rise, that's the numerator here. You take the square root of that, and then whatever under x, the square root of that is our run. So over here for north-south, notice it's a plus or minus a over b because a squared is underneath y. So you take that square root, that's our rise, square root of b squared, giving us b, there's our run. Something else we could look at here are the vertices. Now we're able to, I'm giving you like this little formula or calculation to be able to state the vertices without necessarily having to graph. If you know what h, a, and k are, and you're going to see when we go to graph these in a little bit. All right, so again, go ahead and draw a coordinate plane, whether on your notebook paper or your graph paper. Please use a ruler. You could pause the video to do this and then copy down this problem. First, we need to identify the center. As I mentioned, now the centers are no longer going to be just at the origin. So here, the center is going to be, notice the x comes first. Wherever the x is, that's the h, or the opposite of the number. So h is going to be a -1, and k is going to be a +3. So we have a center at -1, 3. Again, a squared always is our first denominator. So a squared is 49. A is 7. That makes b squared 16. So b is 4. Because the x is in our first numerator, this is an east-west facing hyperbola. And then we'll go ahead and graph this now. So our slopes of our asymptotes, plus or minus, we start with whatever's under y. So that's a 16, which means it's going to be the square root of that. So it's plus or minus 4 over 7. So we could put our center carefully. Now again, all of these, I'm just counting by 1, are -1, 3. And from this center, I'm going to count up 4 and over 7. Count carefully here though. So down 4 and then over 7. And then up 4, 7 to the left. And then down 4, 7 to the left. All right, so we have our rectangle. We're going to draw on our diagonals for our asymptotes. All right, so that we have those. Right, now here, when we go to write in our vertices, and I'm going to show you exactly how we're looking at this. So because this is an east-west, I still need to go to the left and right sides of the rectangle. We want to go right in the middle. And then over here as well. Now you could still count as soon as it's graphed. You could absolutely still count for this. So it looks like we're going 6 over and 3 up. So we have an ordered pair of 6, 3. Over here we're going 8 to the left and then up 3. So if you go back a page, the vertices are going to be, remember it was h minus a. So h is -1 minus a, and then the k value stayed. So then we have a 3. Well, this is where we're getting that -8, 3 from. And then if you took h, which is -1, plus a comma 3. This is where we're getting a 6, 3 from. So you, as long as you have a, h, and k, you could figure out the vertices without even graphing it or before you graph it. So because, again, this is east-west, now we're able to draw in our curves of the hyperbola. Again, keep it very close to the asymptote, go through the vertex, and then towards the other one. Likewise on the other side. Again, we're keeping all of our lessons with conic sections very simple. If any of you end up going into higher math courses, there's other things that we deal with conic sections as well. But there's looking at an example where center is not at the origin. So let's take a look at another one. Now for this one, we need to complete the square. You guys can absolutely use a calculator. So what I want you to do first is pause the video, try this on your own. I will give you a hint. The x's are already together. Since the 4 is the positive coefficient, I want that going first, and then the y's are together. So give this a try, pause it. Like I said, you could use a calculator to complete the square, and then resume playing. All right, so hopefully if you look here, we're going to factor out a 4 only, and then we're going to be left with an x squared minus 6x, and then I'm going to add something at the very end. Next, careful here, because now we need to factor out a negative 25. So we're going to be left with a y squared and actually a minus 10y, because negative 25 times negative 10 will give us that negative 250. Leave a little blank here. I'm going to move that negative 489. I want to add it to the other side, and now we'll figure out what we're going to add here. So going back here to complete the square, half of 6 is 3, 3 squared is 9. But I didn't just add a 9, I added a 9 times 4, so we're going to add a 36. All right, inside the next set of parentheses, half of 10 is 5. 5 squared is 25. But I didn't just add a 25, I added a 25 times negative 25, and that's actually a negative 625. So then I'm going to add a negative or just subtract a 625. So now when I go back, I'm going to have 4 times the quantity x minus 3 squared minus 25 times the quantity y minus 5 squared. If you combine 489 and 36, we're going to get a 525. 525 minus 625 is actually a negative 100. Now this is okay because we're going to divide, and it's okay to still get negatives here. If this were a circle, we would be in a little bit of trouble getting a negative number over there. But now our next step is to divide everything up here by a negative 100. But now what's going to happen is the signs are going to switch. So I'm actually going to get a negative. I'll move that up top. X minus 3 squared. 4 goes in 125 times. A negative divided by a negative is now positive. The quantity y minus 5 squared over 4. And then this is going to equal a positive 1. So what we always want the positive fraction to go first. Now I'm just going to switch these around. It doesn't happen a lot, but it can happen. We're going to have a y minus 5 squared over 4. There's our minus. Quantity x minus 3 squared over 25 equals 1. So that's completing the square. Everything else is what we just practiced in the last example. Our center, careful though, the y comes first. So over here is our h, and then the 5 is our k. So our center is at 3, 5. Again, a squared is 4, so a is 2. B squared is 25, so B is 5. So the slopes of our asymptotes, go ahead and give it a try before I say it. If you were thinking 2/5, you were correct because the 4 is underneath the y, so we're going to use the 2, so plus or minus 2/5. So we'll go ahead and graph this, and at the very end we'll state the vertices. So we're going, again, I'm just going to count by ones here. We're going to go 3 to the right and up 5. From that, I'm counting up 2 over 5. And down 2 over 5. Up 2, 5 to the left, and then down 2, 5 to the left. So we'll go ahead and draw our rectangle. And our diagonals. Now, one thing we didn't state yet is what direction is this? So because at first it looked like it was going to be east-west because the x came first, but then we ended up having to switch this around. So this being with the y's first, this is a north-south hyperbola. So now at the very top, I'm going to draw my vertex right in the middle of the top and the bottom side of the rectangle. Again, it's a little bit of a wide one, and then we'll stay very close to the diagonal, the asymptote here, go right through the vertex and along the other side, and then the same thing over here. All right, so let's try this now. One vertex, because this is now a north-south one, we're actually going to be looking, we keep h the same, so h again is 3, and then we take 5 plus a, the k plus a, so we'll have 5 plus 2. So we should be looking at one vertex at 3, 7. And if we count up here, this is going over 3 up 7. So this is our one vertex at 3, 7. The other vertex is going to be at 3 and then 5 minus 2. So this should give us another vertex at 3, 3, which is right here. All right, so there's an example of completing the square, a little bit more work because we did end up switching this around, and then looking at centers that are no longer at 0, 0. So now off of your worksheet, guys, from the other day, you could work on 3, 4, and 7. Tomorrow I will post the answers to these 3. I might give a few more examples on Monday. And Tuesday of next week, Monday, I will assign a quizzes over hyperbolas, give you guys a couple days to do that, and then I'll provide you with a review over all of conics and probably test you on conics, giving you another quizzes as well. But please, as I always say, email me if you guys have any questions whatsoever. Keep up the good work. Make sure you're looking at these videos and checking your answers. Take care, guys.